All right, number three makes me excited just to look at because I realize that I'm trying to find the nth derivative. That means it's just a game of patterns that I should be able to discover. And we're not doing anything too wild. It's just x e to the x, things I know how to deal with. But x e to the x is a product rule question, right? So let's just go ahead and just take our first derivative, and then we'll have to keep taking a couple more to see if we can find a pattern. So dy dx is going to be our product rule. So derivative of the first times the second plus the second times, oops, derivative of the second times the first. So we end up with something that looks very much like our original problem, right? So we end up with this plus x e to the x. So we can see, okay, we already have sort of a repeat happening of what we had before. We could even rewrite this with a factored out e to the x, but I don't know that that's going to be super helpful for us. So let's just go with this version right here. I'm going to stick with this version because I do know I can leverage the fact that I just found the derivative of that. It's going to be like a nested version of this, right? So like this piece that I just highlighted, bloop, bloop, we already know the answer to that. This is e when we take the second derivative. Let's go ahead and write down what we're doing so we don't get in trouble. Second derivative, we know that this is going to be e to the x plus e to, oops, I'll write it the format we did just now. Um, x, ooh, way too much, e to the x, right? So I'm just rewriting this entire thing that we have because it's going to keep expanding, right? So that is that second bit, that whole thing, right? The derivative of x, e to the x is that, and the derivative of e to the x is, oops, e to the x. I keep pressing the button to switch over. There we go, e to the x. All right, so if we clean this up again, we have 2 e to the x plus x e to the x. So there's that thing coming again. Okay, so if we take the derivative of that, we know we're going to get an e to the x plus x e to the x. Oh, I don't like how I wrote that. Let me fix it. My e is like not at the same place. Okay, there we go. Plus x e to the x, and then we're going to have our 2 e to the x. And so let me go ahead and label this again. This was the third derivative. Okay, so I consider, okay, and so that's going to end up with a 3 e to the x. And we're hopefully seeing a pattern here, right? There's on every single time I'm going to end up with this x e to the x. And I'm also noticing that, oops, on my first derivative, I had a single e to the x. On my second derivative, I had 2 e to the x's. And on my third derivative, I had 3 e to the x's. So maybe I'm feeling comfortable enough now to say, I think I can write down my nth derivative. I'm pretty confident it's going to be n e to the x plus this x e to the x kicker, right? And if you wanted to write that as the factored form, you'd have this, something like that. So either of these would be acceptable, but this, I think the top one is the more obvious of the two. Oh, now I made it look like a fraction. Oh God, undo all of this. Okay, so there you go. So or that. Cute. All right, that was number three. Not as bad as it seemed, right? I do love looking for those patterns, and they come up all the time with our exponentials and with our trig derivatives as well.